So here I'm going to demonstrate my new laser engraver cutter to you. Cuts black paper, and I'm using a red laser, and I put the black paper on the engraving plateau and fix it with magnets. So now it's all set to start. Gonna start my G-code sender and send the G-code. The whole process will take about 8 minutes to complete. The laser is running at approximately 180 milliamps. It's rated at 200 milliamps continuous power, but at the moment I can't get enough current from the from this device. It's a fault and current limiting DC to DC converter. It takes at least 7 volts to function. I've hooked it up to a 12 volt power adapter, but it provides only the 180 milliamps roughly. I can't seem to get it any higher. Well, it's the laser power source. The laser power source is we call it turned on and off via the yellow signal. It's the spindle power, and the spindle power actually triggers this transistor. I think it's an NPN222. I'll have to verify that, but this would actually turns on and off the laser. Here you see the 2 stepper motor drivers. They are easy drivers, and they are hooked up to the Arduino, and they use 5 volts because the stepper motors from the DVD players take 5 volts. You can run them at higher voltages to, I tried 9, but then the motors get really hot, and at 5 volts they do a good job. And the Arduino Uno that you see here, it has been flashed with GBRL, which takes the G-code from the G-code sender that I have on my laptop. In the next few days I will try to install the G-code sender on my Raspberry Pi. So the Raspberry Pi will send the G-code to the Arduino, and the Arduino in turn is controlling the laser cutter engraver. Well, most of I got off via eBay. It's really easy to get all the necessary stuff from there, and for the laser it's probably wise to wear some protection. I bought some of these glasses, got a couple of them, because the laser is actually quite dangerous. It has 200 times the strength of a laser pointer, which is normally rated at only 1 milliamp, milliwatt, milliamp, I don't know. So be careful if you try this at home. Take all necessary precautions because you got only one set of eyes. Well, the laser cutter is now exactly halfway through its steps. It needs to take 255 steps and it's at 128. And the software says it needs 4 more minutes to complete. Putting together the whole thing was not extremely difficult, but no, I really have a difficult time soldering and getting all the right parts together. And yeah, turning on and off the laser. In hindsight was quite easy, but I used the wrong port in first instance. I was advised to use the coolant port because it should turn on and off when the laser is supposed to turn on and off, but it didn't work for me. So I used the spindle on and off connection to turn the laser on and off. And well, the stepper, hooking up the steppers was really easy. It's very well documented in the GBRL documentation. You basically turn on and off the stepper motor and tell it in which direction it has to turn and hook up the ground. And well, I think that's about it. It's not that difficult. I used the inside of 2 different DVD writers, but I didn't use the red laser from the DVD. I bought one at eBay, also with the laser housing. It's not really getting warm and probably not driving it hard enough, but it cuts the paper, so it's hard enough. It drives it hard enough. So the cutting line is so fine that it's very difficult to see where the laser has cut. An easy way to see is to put a light source behind it. I'll show you in a minute. Okay, that's it. I'll turn off the software and now I'll take away the magnets. So, and at first you don't see anything until I put some light behind it. I'll use the camera. See? Oops. You can see the cutting. And let's keep it in front of the camera. Oh, I have to put up my glasses. And I need some tools to poke out the eyes. Oops. You can see it. It's actually quite precise cut. I can't see it where I put it. Hang on. What's that? Alright, that's it. Thank you for watching.